Okay, so they've given us a probability question. We'll get to the title after because we have to read the question before we know what to use. 8 horses in a race. In an attempt to predict the finish of the race, 3 horses are selected by lot to finish first, second, and third. So a very specific outcome. What's the probability that this choice is not correct? Okay, so we'll make a quick diagram here. Actually, I'll choose some shapes here to represent the horses. Sure, let's use this. These are our horses. So 1, 2, 3, 4. Does it go down? Yeah. 5, 6, 7, 8. So these are our 8 horses. Let's assume, they're on their starting line here and they have the exact same probability of winning the race, all of these guys. Some bystander on the side, smiley guy, predicts that the horse closest to him will become first. The next horse will become second, and the next closest will become third, mainly because they're just closest to him. Easiest for him to guess that. There's many possible outcomes. So just to give you an idea, this A is one possible outcome. Another possible outcome, so we'll call it outcome 2, could be, yeah, he might finish first, but maybe this guy finishes second, and this guy finishes third. That could be a second. And then the third possible outcome could be, yeah, he could still finish first, and maybe he finishes second, he finishes third. So this process, as you can see, as we kind of just go down the horses, is going to repeat many times. So in order to figure out how many possibilities are, we're going to take into account how many horses there are and the specific placing of 3. Okay, and that's where a permutation comes in. A permutation is when order matters. So these 3 horses, it's very important in what place they finish. So instead of using a combination where order doesn't matter, we're going to use a permutation. So it's always in the question. It'll kind of explain itself whether it's going to be a permutation or a combination. If order doesn't matter, we'll use combinations to find out the total number of outcomes. So we'll call the outcome NS, or the number of outcomes NS. And in order to figure that out, we use our permutation with our number of choices, which are our 8 horses, and we've chosen 1, 2, 3 of them. Okay, so we're taking the place of 3 of them. This formula is usually written P. Let's say this is, I think they use R and N or S and N.
N and R.
N and R, is that it? Yeah. So it's written like this. This permutation is written as N factorial over N subtract R factorial, I believe. Okay. So in this case, our 8 is N and our 3 is R. So we're going to be replacing R with 3 and the N's in this equation with 8. So our NS, or our probability, is equal to 8 factorial divided by 8 minus 3 factorial, right? We'll quickly do that fraction there. 8 minus 3 will be 5, so we have 8 factorial divided by 5 factorial. Well, since we'll briefly write this over here on the side to do a quick calculation, we know that 8 factorial is 8 by 7, 6, 5, 4, 3, 2, 1. Okay, 2 and 1. And we know 5 factorial is 5 by 4, by 3 by 2 by 1. Well, since this is a division question, and it's all multiplication on top, we know that these guys are all going to cancel each other out. So really what this leaves us with is 8 by 7 by 6, which is the possible number of outcomes. So how many different ways these 8 horses could actually finish. So we already calculated this. 8 by 7 by 6, what did we say it was?
336.
Yeah, let's put it on a calculator. 8 by 7 by 6. You're a math genius. Did that in your head. 336. Okay, so we know the total number of outcomes is 336 possibilities. And this guy over here who chose it, there's only one way that this could happen where this guy finishes first, this guy finishes second, this guy finishes third. So in other words, the probability that his choices are correct are 1 in 36. Okay, but if we pan out just a little here, the question is not correct. Okay, so probability of this not being correct, to figure that out, we would take 1 and subtract this probability. Right? So the probability of the event happening. 1 subtract probability is the probability of the event not happening. So in this case, the probability is 1 over 36. We have 1 subtract 1 over 336, which is going to be equal to 335 over 336. Does that make sense to you?
Mm-hmm.
So as a percentage, he's 99.7% chance that this guy is incorrect with his 3 choices. Okay? 99.7% chance that this guy is not correct in this question.